Hi there, my name is Daniel Yellow. Welcome to the course Introduction to Graph Algorithms for Game Developers by Packt Publishing. I have worked professionally with software development for more than 8 years and I've worked professionally as a game developer. My fields of expertise are artificial intelligence and procedural content generation. I am the author of the UnityNeat library, which is a port of SharpNeat made to work specifically with the Unity game engine. UnityNeat can procedurally generate artificial intelligence through neuroevolution. This library was created as part of my master's degree in game technology. This course will serve as an introduction to graph algorithms in the context of game development. We will learn the theory behind graphs and algorithms in an easy way, presented with many examples and implementations. We will start the course by gaining an understanding of what a graph is. We will go through the theory behind graphs and we will implement simple graph and tree structures. The section ends with a discussion of how graphs can be used in games. In the second section, we will start implementing algorithms that work on graphs. We will focus on algorithms that can search the graph, as they have many applications in game development. We will implement 2 algorithms, breadth-first search and depth-first search, and see the pros and cons of these. In the end of the section, we will use the algorithms to solve a puzzle game. In the third section, we will use searching for pathfinding. We will see an algorithm that always finds the shortest path, called Dijkstra's algorithm, and we will see how we can implement our algorithms in grids as well as graphs. In the fourth section, we will see how we can optimize our searching algorithms by using heuristics. We will implement 3 different pathfinding algorithms that use heuristics, including the very popular A* search algorithm, and we will understand why A* search works so well. In the last section of the course, we will put the searching algorithms we've learned in the course to use. We will design a Pac-Man-like game, and we will use the algorithms we've learned in the course to create 3 different AI behaviors for the enemy ghosts. In the end, we will define a state model that determines when the ghost will transition to the different AI behaviors. The target audience for this course are aspiring game developers and hobbyists who already know the basics of programming and have tried fiddling around with the game engine, and game developers who want to take their games to the next level by adding pathfinding or puzzle solvers to their games. To get started with this course, you should already have a basic knowledge of programming and be interested in game development. During the course, I will be using C# as programming language, but the concepts will be presented as language agnostic as possible, so you can easily follow this course if you're using a different language. The goals of this course are to give you an understanding of graphs, trees and grids, to give you knowledge about different searching algorithms, to enable you to use searching to solve puzzles in your games, to use pathfinding in your games, and to give you the tools you need to be able to reason about which algorithms to use in different situations. Now that we know what lies ahead, let's jump right into the course.